Have you ever wondered how the largest planet in our solar system, Jupiter, came into existence? The birth of this colossal gas giant traces back to the nebular formation, a cloud of gas and dust left over from the sun's creation. Within this nebula, a fascinating dance of cosmic particles took place. The dust particles started to collide and stick together, forming larger and larger clumps, eventually creating solid bodies. Among these bodies, one stood out: the protoplanetary core of what would become Jupiter. This core was a product of a wide variety of materials, from rock and metal to water ice, all gravitating together under the right conditions. As the clumps grew, they started to attract even more material, snowballing into a larger and larger entity. As the core of Jupiter began to take shape, it set in motion a series of events that would eventually culminate in the creation of the gas giant we know today. The protoplanetary stage was a critical period in Jupiter's formation. During this phase, the fledgling planet began to flex its gravitational muscles. Jupiter's core, made primarily of heavy elements like iron and rock, started to pull in nearby gases, growing ever larger and more formidable. Picture a snowball rolling downhill, gathering more and more snow as it descends. That's a simplified analogy of what Jupiter's core did with the gases in the early solar nebula. It attracted and accumulated hydrogen and helium, the most abundant elements in our universe. These gases not only bulked up Jupiter's size but also contributed to its unique composition and colossal mass. Now here's the interesting bit. The core accounts for just a fraction of Jupiter's total mass, yet it's the heart of the planet, the gravitational anchor that holds everything together. The protoplanetary core was the foundation upon which the mighty planet Jupiter was built. Jupiter's atmosphere is a dynamic and complex system. It's a swirling, ever-changing landscape that tells a story of the planet's internal workings. Imagine a world where cloud bands of ammonia and hydrogen sulfide stretch across the horizon, creating a mesmerizing vista of colorful streaks. These bands move at different speeds, driven by the planet's rapid rotation and heat rising from its core. Now, picture the intense storms that rage within these bands. The Great Red Spot, for instance, is a tempest larger than Earth that has been churning for at least 300 years. These storms are not merely surface features, they signify deeper atmospheric processes, shaping Jupiter's climate. The atmosphere also hosts lighter zones and darker belts, each with their unique weather patterns. It's a dance of dynamic forces where rising warm gases meet cooler descending ones, creating a cycle of turbulence and tranquility. Jupiter's atmosphere is a swirling, stormy spectacle that is as beautiful as it is complex. Deep within Jupiter, a dance of energy and elements is taking place. This celestial waltz unfolds in the planet's internal layers, each with its unique composition and characteristics. Starting from the outer atmosphere, where swirling storms larger than Earth reveal an active and dynamic world, descending further, we encounter the convective region. Here, heat from the core rises, creating currents that drive the planet's powerful weather systems. This region is a crucible of intense pressure and heat, where hydrogen behaves like a metal and generates Jupiter's immense magnetic field. At the heart of it all is the core, a solid mass of rock and metal. Its precise composition is a subject of ongoing debate, yet its presence is undeniable. It's the gravitational anchor around which the rest of Jupiter coalesces. These layers interact in a complex ballet, transferring energy and materials in a continuous cycle that shapes Jupiter's overall structure. The inner dance of Jupiter is a testament to the complexity and wonder of our solar system. Jupiter's magnetic field is a force to be reckoned with. The strength of this field is incredible, over 20 times stronger than Earth's. This immense magnetic force acts as a cosmic shield, deflecting harmful charged particles away from the inner solar system. Imagine a celestial bodyguard standing tall and strong, warding off the cosmic radiation that could potentially wreak havoc on the inner planets. That's Jupiter for you. Its magnetic field creates radiation belts around the planet, trapping these particles and preventing them from advancing further into our solar system. There have been specific instances where this magnetic shield has proven crucial. For example, during solar storms, when the sun spews out a massive quantity of charged particles, Jupiter's magnetic field acts like a protective barrier, ensuring the safety of the inner planets. Jupiter's magnetic power is not just a spectacle of nature, but a guardian that shapes and protects our solar system.